Right now, as you're looking at this screen, 97% of your body mass is made of atoms forged in stars. Only 3%, primarily lightweight hydrogen, is a legacy of the Big Bang. Consider a tangible example: an iron atom in your blood. It didn't just appear, it was forged at temperatures exceeding 600 million degrees in the core of a giant star. That's 100,000 times hotter than the sun's surface. Then, ejected by a supernova explosion, it journeyed through space for millions of years to become part of the hemoglobin that, at this very second, is carrying oxygen through your body. This gives rise to a central paradox. If we are literally woven from stardust, why do we feel separate from the cosmos? This connection is deeper than it seems, full of mysteries that science is only just beginning to unravel. The first of these is a human story. How could scientist Fred Hoyle, who developed the key theory of element formation in stars, simultaneously and vehemently deny the Big Bang? He disbelieved in the universe's beginning so strongly that he coined the term Big Bang as a derogatory nickname. The answer to this scientific mystery awaits you in the finale. The second mystery is cultural. How could humanity gaze at the stars for thousands of years, even deifying them, yet never realize they were looking at the very factories that created their own bodies? Why was this truth hidden for so long? These aren't just puzzles. They are milestones on the path to a profound promise that will change your view of the world. By the end of this video, you won't just have a collection of facts, you'll have your own personal cosmic passport. We'll unveil its 6 key chapters one by one, from primordial hydrogen to gold, born from the collision of neutron stars. This knowledge will transform how you see the most ordinary things. A drop of your blood will become the echo of a supernova explosion. A glass of water, a witness to the universe's birth, and distant points in the night sky will transform into your ancestors. You'll understand that you don't live in the universe lives within you. But to obtain this passport, we must journey to the very beginning, to a time when the universe was almost empty, and the creation of even a single carbon atom seemed impossible. 13.8 billion years ago, the universe was like a kitchen with an endless supply of only 2 ingredients: flour and water. You could make paste from them, but baking a complex cake would be impossible. After the Big Bang, cooling energy transformed into matter, but this process yielded only the 2 simplest elements: hydrogen and helium. 99.9% of all matter was fuel from which neither a planet nor a cell could be built. It was a universe of colossal energy, yet cosmic boredom. And the key to the mystery lay not in cosmology, but in a discovery that the scientific world initially refused to accept. In 1925, 25-year-old graduate student Cecilia Payne, analyzing the light from distant stars, reached a revolutionary conclusion. The Sun and other stars consist of the same hydrogen and helium as the early universe. It was a breakthrough. Yet her advisor, a prominent astronomer, deemed it absurd. He forced her to personally include a phrase in her dissertation, stating that her own conclusions were probably not real. He believed the Sun's composition was similar to Earth's. Years later, Cecilia's correctness was proven, but this only deepened the mystery. If stars are merely giant balls of hydrogen, how could they create the complex elements that make us? The answer lies in a simple yet astonishing fact about your body. 63% of all your atoms are hydrogen, a legacy of the Big Bang. Yet, all of them combined way less than the oxygen atoms alone, which are almost 3 times fewer in number in your body. By atom count, you are a hydrogen being. But by mass, by structure, by the very biochemistry of life, You are those rare and heavy elements that make up almost 90% of your weight. Your self is defined not by the majority, but by a tiny minority. That's why, to understand ourselves, we had to find the source of these rarest yet vital atoms. So, the picture is clear. The early universe gave us an almost infinite supply of fuel, hydrogen. And Cecilia Payne's discovery proved that stars are giant balls of this very same fuel. This was a scientific dead end. You have fuel, but not a single atom of carbon, oxygen, or iron. Life is impossible. To create you, the universe needed not just fire, but a true industrial forge, capable of melting down the very fabric of reality. And it created it in the heart of stars. Within this forge, nature faces an impossible task. How do you fuse two hydrogen protons when, like identical magnetic poles, they repel each other with colossal force? The answer is brute force. A star's gravity, like a giant press, compresses its core until the temperature reaches 15 million degrees, and the pressure 250 billion Earth atmospheres. In this inferno, protons move so fast they have no choice. They collide and fuse, giving birth to helium. But this is only the first step. The universe learned to make helium, but how do you create carbon, the basis of life, from it? For that, an almost inconceivable triple collision is needed. To get one carbon atom, 3 helium nuclei must collide almost simultaneously. It's like trying to hit 2 flying bullets with a single arrow. Statistically, this event is so improbable that stars simply wouldn't have had enough time to produce sufficient carbon for our existence. And here the universe reveals its ultimate trick. Fred Hoyle, the very scientist who denied the Big Bang, predicted, "Since we exist, helium and beryllium nuclei must possess a special property, a resonance that vastly increases their chance of fusion." He was right. This property, the Hoyle resonance, was found. It's a delicate tuning of the laws of physics, without which neither you nor I would simply exist. Thus, carbon is born, and then, in a chain reaction, oxygen. The factory was in business. Let's pause for a second. This information might seem complex, but its essence concerns each of you. Imagine you're holding an ordinary pencil with a graphite lead. That's almost pure carbon. Do you realize now that every atom in that object, trillions upon trillions of atoms, once went through that incredible triple process in the scorching core of a long-dead star? Look at your fingertip. It's 18% made of precisely those same atoms. That's an astonishing thought. Type carbon in the comments if you'll never look at it the same way again. So, we've unraveled the secret of the cosmic forges. Stars are factories that take the universe's simplest element, hydrogen, and through incredible challenges, transform it into the matter of life, carbon and oxygen. But like any factory, stars have a limit. The fusion chain effectively stops at iron. Creating elements heavier than iron is energetically unfavorable. It doesn't release energy, but absorbs it. This is a dead end. To obtain the most important metal in your blood and scatter it across the cosmos, a star must stage the most magnificent fireworks display in the universe, its own death. Every massive star is doomed. When its core runs out of fuel and only iron ash remains, gravity delivers a crushing blow. In fractions of a second, the Earth-sized core collapses to the size of a city, releasing energy comparable to the light of all stars in the observable universe. This collapse triggers a shockwave that tears the star apart. This is a supernova explosion, and it is not death. It is the most powerful act of creation. A star's life is like one long inhale. For millions of years, it draws in matter, compressing it in its core. A supernova explosion is the most powerful exhale, scattering the seeds of life throughout the galaxy. But how exactly is this cosmic violence connected to your ability to breathe? The answer to that question lies in the 4 grams of iron in your body. Every atom of that iron, which is currently carrying oxygen from your lungs to your cells, wasn't just created in a star. It was born in the agony of its final seconds and blasted into space by the explosion itself. Ejected at speeds up to 30,000 kilometers per second, fast enough to circle the Earth 22 times in 1 minute. It traveled through the void for billions of years to become part of a hemoglobin molecule. When you feel your pulse, you are actually feeling the echo of a distant supernova explosion. But how did this stardust, scattered across the galaxy, manage to coalesce to create planets and, ultimately, you? How could scientists prove such an incredible theory while confined to a tiny planet? The turning point came in 1957 with the publication of the B2FH paper. Its authors, Burbage, Fowler, and Hoyle, became the architects of our stellar origin. Across 104 pages, they first synthesized all available data into a unified theory, demonstrating how stars create almost all elements. But here lies a dramatic paradox. Fred Hoyle, the driving force behind this work, denied the Big Bang until the end of his life. The man who explained how stars make us didn't believe in the universe's beginning. Nevertheless, their theory became an unshakable foundation. They gave us a treasure map. Now, we needed to understand how these treasures got from the map to our planet. So, we've witnessed the most magnificent act of creation through destruction. The explosions of giant stars seeded the universe with heavy elements, including the iron for your blood. But these precious atoms were scattered across trillions of kilometers in interstellar space. They were like dust. How could an ordered world like ours be born from this chaotic cloud of dust? The universe had to initiate its slowest and most patient mechanism, gravitational accretion. And it all began with cosmic dust. This stardust isn't the end of the story, but its new beginning. Giant gas and dust clouds, enriched with everything from carbon to iron, become not graveyards but stellar nurseries. Gravity, the universe's most patient sculptor, compresses these nebulae for millions of years until a new star ignites at their center. Thus, 4.5 billion years ago, our Sun was born, and from the remaining material, this cosmic recycling, Earth and all the planets formed. This process is akin to a forest cycle. Fallen leaves decay, fertilizing the soil for a new generation of trees. We are the direct legacy of stars that died long before us. But how did the first complex organic molecules appear on this planet, assembled from dead stardust and metal? The answer arrived from space. In 1969, a meteorite fell on the Australian town of Murchison. Its analysis was a shock. Inside this rock, older than Earth itself, scientists discovered over 90 types of amino acids, the building blocks of all proteins. Many of them are not found on Earth. These weren't just rocks. They were cosmic packages, delivering complex organic ingredients to a lifeless young planet. They synthesized in the cold of interstellar space under the influence of cosmic rays. Stars didn't just create atoms. They initiated complex chemistry in space that prepared the ground for life even before Earth cooled. But how did this complex scientific idea become part of our culture? One person did this using television. His name was Carl Sagan. In 1980, his series Cosmos became a global phenomenon. Sagan wasn't just an astronomer. He was a master storyteller. He took the complex theory of stellar nucleosynthesis and distilled it into one simple, profound, and poetic phrase. We are made of star stuff. That year, over 500 million people in 60 countries heard this and felt an almost religious sense of connection. Sagan didn't just tell a story. He gave us a new language to describe our connection to the universe. But what exactly does this beautiful phrase mean when we look at our chemical composition under a microscope? So, we've traced the entire journey, from the birth of the simplest atoms in stars to their dispersal by supernova explosions, from their assembly into planets to the delivery of organic seeds to Earth. All the ingredients are in place. We've traveled a path spanning billions of years and trillions of kilometers. Now it's time for the final step, to look inside ourselves and compile a precise chemical passport of our stellar heritage. We'll finally answer the question posed at the very beginning: what are we really made of? In 1 minute, you'll receive a precise breakdown of your passport and discover what percentage of you is made of stars. Here it is, your chemical passport, and its first page breaks all conventional logic. By mass, you are 65% oxygen. But if you count by number, 63% of all your atoms are hydrogen. You are simultaneously an oxygen and a hydrogen being. This dual citizenship is key to your origin. Oxygen, carbon, hydrogen, and nitrogen together comprise 96% of your weight. From Earth's biological perspective, it's simple. Oxygen for breathing, carbon for organic matter. But ask where they come from, and the picture changes. 97% of your body mass, everything except most of the hydrogen, has an extraterrestrial origin. Carbon and oxygen were forged in stellar factories. Iron was born in supernova explosions. And hydrogen is a relic of the Big Bang. For thousands of years we looked at the stars, unaware we were looking in a mirror. But this only establishes citizenship. It doesn't explain why carbon, and not its closest neighbor in the periodic table, became the ruling element of life. Why carbon? Silicon, its chemical twin, is far more abundant in Earth's crust. The answer was embedded in the laws of physics long before Earth's birth. A carbon atom has a unique ability. It can form 4 strong bonds. It's like having 2 arms and 2 legs. It can connect in any direction, creating infinitely complex 3-dimensional structures, chains, and rings, the skeleton for DNA molecules and proteins. Silicon can also do this, but its bonds are weaker. In an aqueous environment, the cradle of life, complex silicon molecules simply fall apart. The strength of the carbon bond is a property forged at billions of degrees in the inferno of a stellar core. Stars didn't just give us material, they gave us the best possible building kit with pre-programmed properties. But even the supernova explosion that created iron wasn't enough to create all the parts of this kit. This isn't just a collection of facts. This is your personal chronology. The atoms in your body represent 3 generations, 3 epochs of the universe, living within you simultaneously. The first generation, the oldest, is hydrogen. It is 13.8 billion years old. It is a witness to the Big Bang. The second generation, younger, is carbon and oxygen, born in the cores of first and second generation stars. And the third, youngest generation, is iron, ejected by supernova explosions. Your body is a living geological cross-section of cosmic history, where each atomic layer tells of its own epoch. You don't merely consist of these elements. You are the culmination of their long journey, separated by billions of years, which brought them together here and now, inside you. This journey explains 99% of your chemical passport. But the key to our full heritage lies in the last, rarest percent. It might seem the story is almost complete. 99% is nearly everything. The remaining 1% is just trace elements, a statistical anomaly. But it is within this anomaly that the rarest and most precious elements are hidden. If your entire body mass were a skyscraper, All the gold within you would be a single grain of sand. Here too are platinum, uranium, and critically important for life, iodine, without which your thyroid gland cannot function. And these grains of sand are the key to the enigma. They point to an event so monstrous in its power that a supernova explosion next to it is merely a firecracker. A supernova is powerless to create gold. For that, a cataclysm capable of literally shaking the very fabric of space-time is required. And it awaits us in the next chapter. This event is the merger of two neutron stars. These are dead cores left after supernova explosions. Objects the size of a city, but with a mass greater than the Sun. 1 teaspoon of their matter weighs 6 billion tons, more than all of humanity. When two such stars, orbiting, collide, they don't just explode. They shake space-time, generating gravitational waves. It is in this seconds-long inferno that a neutron flux of such density arises that atomic nuclei instantly capture them, transforming into gold, platinum, and the iodine necessary for your thyroid gland to function. Your wedding ring and your metabolism were born in the same cataclysm. And this brings us back to the man who predicted it all yet rejected the beginning. We left Fred Hoyle, the genius who explained our stellar origin, but denied the Big Bang. His idea was the steady-state universe, eternal without beginning or end, where matter is continuously created from nothing, maintaining balance. It was elegant and avoided the question of what came before. But the greatest irony awaited him in March 1949, in a BBC studio. Attempting to ridicule his rival's theory, Hoyle, with disdain in his voice, uttered the phrase, "This Big Bang idea." He didn't realize he had just given an immortal name to his primary scientific adversary. Science progresses not through infallible prophets, but through the clash of ideas. Hoyle gave us both the key to our origin and the name for the universe's birth. Have you ever championed an idea so fiercely that you overlooked your opponent's correctness? This story reminds us of the value of rare events. All the gold ever mined by humanity would fit into a cube 22 meters on each side. It seems like a mere luxury, something we could live without. Yet, in those same cosmic collisions, iodine is born. Without it, your thyroid gland, which regulates your entire metabolism, cannot function. Its deficiency leads to irreversible brain development disorders. It turns out that the most complex forms of life on Earth, our ability to think, directly depend on an element that our galaxy produces roughly once every 10,000 years. Your consciousness exists thanks to one of the rarest and most catastrophic events in the universe. This chain of events is complete. So, where does this journey end? We've learned that our hydrogen comes from the Big Bang, our carbon from stars, our iron from supernovae, and gold from the merger of neutron stars. But this isn't just a collection of facts. These are chapters of one continuous odyssey. An atom currently in your cell was once part of a primordial cloud, then burned in a star's core, was ejected by an explosion, wandered in the void for billions of years, and finally became part of you. This journey is complete. From the hydrogen of the Big Bang to the iodine from colliding dead stars, the entire 13 billion-year history of the cosmos isn't written in books. It's written in your DNA. In the final section, we'll understand how this knowledge forever changes our view of ourselves. This knowledge transforms disparate facts into a single, unbroken thread, stretching from the very point of the Big Bang. It's a cosmic relay race, lasting an eternity. Chapter 1. The Big Bang creates primordial hydrogen and passes the baton. Chapter 2. First-generation stars receive it and, in their scorching cores, transmute it into carbon. Chapter 3. Their death in supernova explosions complicates the relay to iron. Chapter 4. Stardust, like a cosmic mail carrier, delivers this material across the galaxy for billions of years. Chapter 5. Your body's chemistry assembles these atoms into the most complex molecules. And Chapter 6. The mergers of dead stars add the final, rarest touches, like iodine for your mind. The end point of this relay, the finish line, is you, here and now. These aren't 6 different stories. These are 6 chapters of one book whose main character is an atom, journeying 13.8 billion years to become you. We've traced this path. Now we'll understand what it means for us. On a cosmic scale, humanity is a tiny speck on the outskirts of an unremarkable galaxy. This feeling of cosmic insignificance is familiar to everyone. But it's based on an incomplete picture. Yes, we are small in space, but we are boundless in time. You are not dust. You are a living archive. A temporal library where the entire history of the universe is stored at the atomic level. Every atom in your body is an authentic artifact. A hydrogen atom in a drop of water on your palm remembers the birth of the universe. A carbon atom in your cell remembers the hellish core of a long-extinct star. An iron atom in your blood remembers the dazzling flash of a supernova. Your body is like a tree ring on the cross-section of an ancient tree. Each ring is a year lived, and each type of atom within you is an epoch of the cosmos lived through. This knowledge is the most powerful antidote to loneliness. You don't just exist in the universe. The universe exists within you. But this gives rise to a final, profound paradox. If we are so inextricably linked to the cosmos, why do we feel separate from it? The answer to this question is perhaps the primary purpose of our existence. For billions of years, the universe evolved blindly. Stars were born and died, unaware of their own magnificence. Galaxies collided in a majestic, yet utterly silent dance. Perhaps consciousness is the mechanism by which the universe finally comes to know itself. Through your eyes, through your capacity to feel awe and ask questions, the cosmos for the first time sees and comprehends its own incredible beauty. We are the universe's nerve endings, its way of feeling. As Carl Sagan, the great poet of science who brought this idea to millions, said, "We are a way for the cosmos to know itself." The feeling of separateness is an illusion. We are not just observers. We are the universe's point of awareness. We've journeyed all the way, from the beginning of time to this very second. Now the main question is addressed not to science, but personally to you. After all you've learned, which of 2 great feelings is stronger within you? The first is awe, a feeling of deep, almost mystical connection with all that exists, a realization of your stellar origin as the greatest gift. The second is loneliness, a keen awareness of the fragility and absolute randomness of this miracle, lost in the cold, silent void. I'm not asking for long essays. Just write one word in the comments below this video: awe or loneliness. Let's see what is more prevalent within us, as a species that has for the first time comprehended its place in the cosmos. This will be our collective emotional snapshot, our shared answer to the universe's 13 billion-year history. Thank you for taking this journey with me.